Imagine a clock that never needs winding, a pendulum that swings forever without losing a single ounce of momentum, and a machine that keeps moving without ever consuming energy. It sounds like a violation of every rule in the physics textbook, right? Well, it sounds like magic, but it's actually a real documented state of matter known as a time crystal. Today, we are breaking the laws of symmetry to see how the impossible is becoming visible in our laboratories. Welcome to SciNova, where we explore the edges of reality. For decades, we believed that the universe followed a very strict set of rules regarding symmetry and energy. We thought that if you wanted something to move, you had to pay for it with energy. But in 2012, a theoretical physicist named Frank Wilczek proposed something that sent shockwaves through the scientific community. He suggested that matter could exist in a state that breaks time translation symmetry, creating a rhythm that exists simply because it exists. To understand this, we first have to understand what symmetry actually means in physics. In a normal crystal, like salt or a diamond, the atoms are arranged in a repeating pattern in space. If you move 3 inches to the left, the environment looks exactly the same. That is spatial symmetry. But time is different. Usually, if you wait an hour, the laws of physics don't change, but the state of a system does. It loses energy, it cools down, or it stops. This is called time translation symmetry. A time crystal is a bit of a rebel. It is a state of matter characterized by the spontaneous breaking of that time translation symmetry. Instead of staying static or decaying into stillness, the internal structure of the crystal changes periodically in time. It repeats its configuration over and over again, not because you are pushing it, but because its very nature demands it. It's as if the atoms are dancing to a beat that only they can hear, even when no one is playing the music. Now, you might be thinking, wait, isn't this just a perpetual motion machine? Isn't this breaking the second law of thermodynamics? It's a fair question. If a system moves forever without consuming energy, it feels like it's cheating. However, there is a massive catch that keeps the laws of physics intact. While the crystal's structure repeats, you cannot actually extract useful work from this motion to power your toaster or your smartphone. The energy isn't being created from nothing. It's just a stable, oscillating quantum state that doesn't lose its rhythm to entropy. This isn't just some wild mathematical theory scribbled on a napkin in a coffee shop. The transition from theory to reality happened much faster than many expected. Around 2016 and 2017, the first laboratory observations of discrete time crystals were successfully conducted. Using highly controlled quantum systems, researchers were finally able to see these rhythmic patterns manifest in the real world. It was the moment the impossible became measurable data. So, how do you actually see a time crystal? You can't just pick one up with tweezers. Scientists use discrete time crystals, which involve systems that repeat in cycles without consuming energy. They often use trapped ions or spins in a magnetic field. By hitting these particles with periodic pulses of energy, they observe that the particles don't just follow the pulse, they respond with their own internal rhythm that is different from the external force. They are essentially running on their own internal clock. The distinction between discrete and continuous is where things get really mind-bending. Most of what we've observed so far are discrete time crystals, where the pattern repeats at specific set intervals, but researchers are now pushing into the realm of continuous time crystals, or CTCs. These are systems that break continuous time translation symmetry. Instead of a rhythmic tick-tock pattern, they exist in a state of constant, flowing oscillation that doesn't rely on periodic external triggers. It's the difference between a blinking light and a constant waving ocean wave. Why does this matter? Why are we spending billions of dollars and thousands of hours studying something that can't even power a light bulb? Because time crystals are a gateway to the future of quantum computing. In a standard quantum computer, information is incredibly fragile. the slightest bit of heat or noise can cause decoherence, which is basically the quantum state collapsing and the calculation failing. But because time crystals are inherently stable and rhythmic, they could act as a way to protect quantum information. If we can harness the stability of these crystals, we might be able to create quantum memories that stay coherent for much longer than currently possible. We are talking about computers that can solve problems in seconds. That would take today's supercomputers millions of years. The time crystal isn't just a curiosity, it's a potential blueprint for the most stable architecture in the history of computation. It's the bridge between the chaotic quantum world and the structured world we inhabit. But let's step back for a second. Even if we never build a quantum computer with them, the mere existence of time crystals forces us to rethink our fundamental understanding of the universe. It tells us that the laws of physics are more nuanced than we once thought. It shows us that symmetry isn't just something that happens in space, but something that governs the very flow of time itself. We are learning that the universe has rhythms we are only just beginning to hear. It's a humbling thought. We spent centuries thinking we had the universe figured out, only to find out that at the smallest, most fundamental level, there are states of matter that seem to defy our intuition. The discovery of time crystals is a reminder that science is never finished. Every time we think we've reached the end of the map, we find a new ocean to cross and a new set of rules to learn. The mystery of time is far from solved. So, the next time you look at a clock, remember that time isn't just a way to measure your commute or your lunch break. In the quantum realm, time is a canvas, and matter can dance upon it in ways we are only just beginning to comprehend. The time crystal is proof that even in a world of strict rules, there is always room for a little bit of beautiful, rhythmic rebellion. Thanks for watching SciNova. If you want to keep exploring the weirdest corners of our universe, make sure to hit that subscribe button and ring the bell. We'll see you in the next dimension.